potential? So do you know the flow of charges?
Yes, sir.
Jocelyn, what is flow of charges? What is current? In other words, current is flow of electricity. Jocelyn, current is flow of charges, right? Flow of charges through circuit. Actually, Jocelyn is typing the messages. Is visible to you, Ridwan?
No, sir.
Okay,
No.
it's the private message, I think,
Yes,
personal
sir.
messages. So, Jocelyn, it will be good if you speak. So, Ridwan, I asked, what is a flow of charges?
Electric current.
Electric current. Okay. So, suppose we have a thin wire. Okay, let me do one thing. Okay, okay. Okay. Now screen is visible to you.
Yes, sir, it is.
It is. So my question was flow of charges. What is this flow of charges in circuit? Suppose we have a resistance, okay, or you may say we have a bulb, right?
Yes.
So we have not connected this bulb to a cell, is open.
Yes, sir.
So can you say that bulb will glow?
No, sir.
So how it will glow?
By connecting it through a wire or a thing.
Okay, unless and until we won't connect, it won't glow, right? That's the simple phenomena.
Yes, sir. Yes, sir.
So in another way, if we will connect the circuit, we will be giving it a driver, okay, which drive the vehicle or something that will
Yes, sir.
drive the electrons through the circuit. If the circuit will complete, the ball will glow, right? So my question is that if the same bulb is over here, I'm not connecting it through the circuit. So charge will flow in this case or not?
There is uh, no, sir.
The charge will not flow unless until it is not connected to the cell.
Yes, sir. Yeah.
Cell means a potential
Electric.
difference. In other word, potential difference. Right? So what does the cells do? It create a potential difference between 2 points. Got my point?
Yes, sir.
Jocelyn, I have to again come to the screen to read your message again and again. It will be good if you speak, if you don't have any problem. Otherwise, we have to do. So, what is the message over here? That charge itself never flow. Got my point?
Yes.
So to drive the charge, we need potential difference. So can you tell me uh, what is charge? Do you know anything about what is charge?
Yes, sir.
What is it?
The current flowing of electricity.
Q is equal to I time T. What is I? I is current and T is time. That is current is charge, flow of charge per unit time. Current is flow of charge per unit time. May you say that flow of charges per unit time, right? But I'm asking some basic question, simpler than this. How charge get into the picture? How electrons get into the picture? In another way, we may say that electron.
The negative
Instead
charges.
of this metallic wire, okay, if I connect this with a wooden block, will work?
No, sir.
Why?
Because it is a bad conductor of electricity.
Okay, the play of conductor is now in the picture. Jaslyn, what is conductor? What is conductor? Jaslyn, what is conductor? I'm audible to you. Ridwan, Jaslyn is audible to you.
Yes,
Okay, I'm audible to you. My screen is visible to you.
yes, sir.
Okay, Jaslyn, what's your issue? Jaslyn, could you please tell me what's your issue? Okay, so you might have studied about the charges. Okay, when silk is being rubbed by glass rods, then glass rod gets positively charged and silk get negatively charged. Have you heard about this?
Yes, sir.
Okay. Sir, can you hear me? My mic is muted. No, Jaslyn, we can't hear you. Okay. So please make yourself audible. Otherwise, discussion will be not very much interesting. So charge is a quantity which only move, I'll say move, when there is some electric field. Whenever is a charge, it creates electric field. So we don't have to go into the electric field in that much details, but a battery or cell, this is the symbol of battery, right?
It's sir.
Exactly. So which one is a positive terminal, which one is negative terminal? Are you aware of it?
Uh, the
Bigger one,
longer
bigger
one,
size,
yes,
longer, yeah. It's positive, it's negative.
yeah, and the smallest negative.
Okay, so we will extend it like that and we'll connect with the bulb and we'll keep a key over here. This is key, this is bulb. So current will flow in this direction and will come over here. So this potential, what it will do, it will try to drag the electron. Electron will come in this way, electron will come in this way, and current will flow in this way. Electron is negative charge, so positive terminal will attract it, right?
It's,
This point is clear? As electron is negatively charged. So positive terminal of battery will attract it. So motion of electron will be in this direction and motion of current will be in this direction, right? This point is clear. Yeah,
From where to where, sir? Can you repeat?
yeah. I said that electron is negatively charged and so the potential, positive potential will attract the electrons. Got the point?
So,
So movement of electron will be in this direction and movement of current will be in this direction, right? Is there any confusion?
no, sir.
Is there any confusion?
No, sir.
Jaslene, what about you? So as the current will flow, some of the current will be, Jaslene is messaging me, so I have to see it. And that distract me a little bit. So, okay. So as the current will be following in this direction, this bulb is glow. Okay. Have you ever made a torch using battery?
Yes, sir.
Okay. So you must be having some hand-on experience. So what happens?
Yes.
This cell do some work, okay, in driving the charges.
Yeah.
So in this way, we can define the electric potential. The amount of work needed to move a unit charge from a reference point to a specific point against the electric field. We, we may not aware that much about the electric field in class 10th. Got my point?
Yes.
But for, for convenience, I will say you, if anywhere there is a charge, this this wire is conducting, okay, this is conducting wire connected with the cell. If you will put a compass nearby it, okay, so compass will get deflected. Ostrad law. Have you heard about it?
Yes, sir.
Have you may can try to get a needle from market and then do it experimentally. Why that happens?
Because the electricity, I don't know, manipulates the compass needle.
Okay, the another way is that, have you seen transformer,
Yes, sir. Yeah.
electricity transformer?
Yes.
Okay, so please don't go near to that.
Okay, sir.
Okay, so what that do, the wire is being wounded on the coils on the some metal, soft metal to create the magnets. Means that if you will put some iron piece over there, that will attract that. Okay, so this is the electric field. Whenever there is charge, that charge will create an electric field around it. So you have to bring a charge from one reference point. Suppose circuit will only complete when a charge will move from this point to making a complete circuit and will come back here and again from any points. If it makes a complete circuit, then only the light will glow. Now it's clear the definition of electric potential,
Yes, sir.
partially or fully.
Sorry.
Fully.
Yes, sir.
Okay, so will you tell me in your own words what is it? What it is?
If,
What is electric potential? My question is that you may say in your own words. Jaslyn, please unmute yourself and try to speak. Okay. Yes. Say me, what is electric potential? See, if you have to drive water from one bucket to the another bucket on the top, what will you do? You will use pump, right? Will you use pump or not? This is on the earth. Okay, this bucket is on the earth and this bucket is on the roof. So if you have to bring some water on the roof, this is roof and this is earth. How will you do that?
using a pipe.
You will imply a motor, electric motor, right?
Yes, sir.
That will drag the water from one point to another point, right? If this is a pot at the roof and here it earth, a pot on the earth. So you will connect a pipe and the water will flow here. Here we don't need any pump because the what at the gravity will do all the work. Here gravity will pull the water droplets from top to earth. Okay. So here the gravity is the agent which drags water from top to earth. Here the motor, electric motor is the agent which pulls the water from bottom to earth. Okay. So in both case, electric motor is doing work. Here the gravity is doing work, right? Same in the electric field. Electric field, same as the electric field. Electric field, you may replace it with motor. Okay. Here the gravity. So what we have to do to bring a charge from this position to some another position, we have to do some work done against the against the electric field. Electric field will obstruct its movement. Okay, electric field will obstruct its movement. So we have to apply some force to bring the electric charges from one point to another point. Clear?
Yes, sir.
That you say me to those statement in your own word. Why you are not able to make it?
It is the move of electric current from one point to another point.
movement of electric charges from one point to another point. In doing that, we have to do some work. It won't go itself.
Yeah.
Got my point?
Yes. Yes, sir.
So we have to do some work in bringing electric charges from one point to another point. If there is no electric field, there will be no work. Just you put and drag it here. But when there is a electric field, you have to do the work against that. Okay, suppose this is a this is Earth surface, and then one charge is over here. This charge is Q. And you have to bring the charge from there to this point. Suppose this is P. In bringing this charge from this point R to P, you have to imply some work. Got my point?
Yes, sir.
Against the electric field. And that's is being called electric potential. Now you speak in your own words.
The work of uh, doing the work of flowing of electricity.
Okay. So Ridwan, can I ask Ridwan? Your
Yes,
name
sir.
is Ridwan, right?
Yes, yes.
So which is your country of origin? May I know that?
What, sir?
Which is your country of origin?
Yeah.
Are you Indian subcontinent or somewhere else?
Down in India.
You are from India.
Yes, sir.
Which part?
Assam.
Assam.
Yes, sir.
Assam, Guwahati.
Yes, sir.
You are from Guwahati, right?
No, sir. It's a
Then
place called Ashigibari.
no, I haven't heard about that. I went there Guwahati once. IIT Guwahati.
Okay, sir.
So that's why you are having trouble in English, right?
No, sir, no, not for that.
Okay, then why you are not able to make the sentence?
Mm, So the yeah, network is stuck.
Your network is lagging,
My
but
network, yeah.
okay, but my question is, I see that you are not able to make the sentence. Okay,
Yeah,
it is
yes, sir.
simple. It is simple to bring a charge from one reference point to another. We have
We
to
need.
do some work against the electric field.
Okay.
Okay, you may note it over here. You note in your notebook. That's
So
the definition.
can you explain the electric field?
Okay, what is electric field? Whenever there is a charge, okay, if there is a charge, say Q, right? So this electric field, this charge will generate an electric field. What is electric field?
Yeah,
If you,
from a charge.
yeah, electric field that if you will, the test of it that if you will put a compass over nearby it, so the compass of needle will get reflected.
Yes, sir.
Actually, in class 12th, we have to study about the electric field and how it generates using Gauss laws and Coulomb's law in detail. But in class 10th, you have to just know about the electric field.
Okay, sir.
As gravity, as Earth push or pull the object, basically Earth attracts the object. That is Earth gravitational field, right?
Yes,
Have you
sir.
heard about it? Earth gravitational force.
Yes, yes.
Okay. So Earth gravitational force F. Okay. Any object is over here, Earth try to pull it down. Earth has one environment. So when we have to send a rocket, we have to provide some force so it go beyond the Earth environment.
Yes, sir.
So similarly, I think it's clear or not.
Yes, sir. Yeah.
So what is it? Now, can you tell me the definition?
Yes.
Yeah. Can you frame it?
The the work the work doing uh, uh, the work done of uh, what's the electric field, pushing against the electric field.
You may
The
write
work
it
done
down.
of yes,
You may write this definition.
uh,
Okay.
yes, sir.
Electric potential is the amount of work needed to move a unit charge from a reference point to a specific point against the electric field. Jaslyn, will you respond? I don't know. She is just listening. So, got the electric potential?
Yes, sir.
The new concept is potential difference. What is potential difference? Have you heard about it anywhere in your life?
Yes, sir.
No. So have you heard about the electric potential? Jaslyn,
Yes, sir.
so what is electric potential?
It is the amount of work that is needed to make charged particles travel from one point to
It's
another point in the
hardly
electric
it's
field.
hardly audible to me. You have to speak little louder. You have to speak little louder. It's not audible at all.
So, can you hear?
It's not audible to me at all. Okay. Jaslyn, you may be having some internet problem, right? You have some internet problem?
No, sir.
Okay. So another concept is potential difference. The difference, the difference in electric potential between 2 points in the circuit is called electric potential, or the potential difference. Actually, we already see in this diagram that there is a bulb. This is the simplest circuit. Here it is potential called, suppose it's the point V at A. So here will be potential VA. After this element, there will be potential VB. Okay. So whenever, because of this resistance or bulb, just okay. So we see in examples. Okay, sorry for that, for delay. This is on the Earth's surface. We have two containers. Okay, so it is filled with water. Both is filled with water. So can electric field, sorry, can the water flow from one to another? Will water flow from one bucket to another bucket?
Can you repeat?
These two buckets filled with water are kept on the earth's surface, and we have connected this with a pipe. Okay, so water will flow from one to another?
Yes, sir.
If water is filled at the equal level?
If, the two buckets are already connected, then
Yeah,
it might not flow.
yeah. If one is on the top and another at the bottom, and we connect it a pipe, will water flow if it's empty or
Yes,
something like
sir.
that? And can it happen?
Yes, sir. It will flow.
In the same way, the electric charge will only flow if there is potential difference. Got the point?
Yes, sir.
So potential difference is the quantity or the thing which helps the charge to flow. And it happens, the flow of charge always happen from higher potential to lower potential. Higher potential to lower potential. Got the point?
Yes, sir.
Okay, so what is the measure of potential difference? Voltage. Voltage. Right?
Sir,
Yes, sir.
can you repeat what is voltage?
The measure of potential difference is voltage. Have you seen that 220 volt?
Yes, yes, sir.
What is
In
this?
it's in flux and all.
Flux? No, it's nothing to do with flux.
Not sir, not flux. Flux. So we can
Flux,
no
right?
sir. Flux. Plugs.
PA,
No L. Plugs.
yeah, this one.
Yes, sir. Yeah.
What is it?
Flux. Sir.
I,
Charges and all, sir. Charges and all.
okay, so
Wires.
wires and all. So have you seen that electric wire roaming around the villages or cities?
Yes, sir. Yeah.
Okay. So for domestic distribution, if you will see that they rate themselves to 20 volt.
Yes.
It means that if you are dragging a wire to your home and you earth it, you will get the potential difference between them 220 volt. And appliance that have rating of 220 volts will work well.
Okay.
You may see the charger, there might be written mobile charger, any apparatus. It is being written that is 220 volt, right?
So what if it is more than 220?
It will burn.
Okay.
Yeah, it will burn. So that's why in domestic supply, it is being provided 220 volt. Otherwise, you may say 1 lakh voltage power supply. Okay, so there are different type of power supplies, but in domestic, we are only given 220 volts.
So
So
what if
how, sorry?
what if the wires are instead of up it's underground?
That's the transmission. Okay, you may
Yes.
transmit it underground, undersea, over the ground. Okay, nowadays, earlier it was naked wires. Okay, everywhere in the India. Now they are
Yes.
covered. The wires are being covered, plastic covered or PVCs like that. So it depends upon the possibilities and resources, right?
Yes, sir.
Okay. So if we have to define a potential in some mechanical way, how we will define? See, we as says that potential difference between 2 points, work done per unit charge. Work done. We have to do work. We have to do work if we wanna drag or transport 1 unit of charge from one point to another point, right? If we have one charge, we have to do some work. If we have more number of charges, we have to do more work. So what is unit of work?
W,
What is unit of work?
the W,
W is the symbol.
Joule.
Yeah, Jaslyn. And Q is the charge. Work done is joule, right?
yes, sir.
And charge is coulomb.
What?
Charge is coulomb. Coulamb. Coulomb. The unit of work done is joule, and that of charge is coulomb. Any problem? Everything is okay?
What me?
Partially. So it will be cover over here. The SI unit of electric potential difference is voltage. Okay, SI unit. What does it mean? SI unit. Jaslyn, what does it mean? SI unit. We have kilogram, meter, second unit. Okay. Then we have foot, pound, and seconds. Okay. Then we have MKS kilo, MK, that's and one another unit kilogram, meter second. This another set of unit as well. Okay, this is foot pound. This is British unit. This is kilogram meter second. This is SI unit. Standard international standard units. It is being accepted all around in the scientific community, right?
Yes, sir.
Yes, sir.
So this unit is voltage, named after Alessandro Volta. He was around 745 to 827. Okay, an Italian physicist. 1 volt is the potential difference between 2 points in the current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to another point. Now it's clear?
Yes, sir.
That potential difference between 2 points in a current carrying conductor when 1 joule of work, unit joule of work, is required to move unit coulomb of charge from one point to another point. Clear? Any confusion?
Yes, sir.
Jaslyn, it's clear to you?
Yes, sir.
Hope it's clear to you. You didn't participate in discussion. Now, do this numerical. Read the problem. This is point A and this is point B.
Yes.
The corresponding voltage at point A is VA and at B is VB, right? How much work is done in moving the charge of 2 coulomb across two points having potential difference of 12 volt? So this has potential difference of 12 volt, right? You have a charge of 2 coulomb. Suppose you have to,
Coulomb
sorry, coulomb is the unit of charge, right? As potential difference is the voltage, force is the Newton, similar way, right? Got the point?
Sir, can you repeat?
Coulomb is the unit of charge
Yes, sir.
as the potential has voltage and work has Newton. So how you will solve this? So work done is,
It's Q into uh, B.
Jaslyn, will you solve it? How much it will come?
So we have to multiply Q into V. So
Yes.
we'll get 12 into 2, which is 24 joules.
So is Q is 2 and this is 12. So it will be 24. Work done, the unit of work done is
Joules.
Joule, right? So is clear?
Yes, sir.
Yes, sir.
All concepts are clear?
Yes.
So Jaslyn, will you say what is potential difference? Jaslyn, what is potential difference?
Sorry, sir.
What is potential difference?
Potential difference is the amount of the work done um, to move a charge from one point to another point in a circuit.
Okay, then what is potential? Electric potential. What is electric potential?
Mm, Electric potential is it is
What is electric potential?
it's the work done to move a charge.
You
Mm,
this time you are saying the right. Earlier you made mistakes. You are confusing with electric potential and
Yes,
potential
sir.
difference. Electric potential difference, right?
Yes, sir.
Okay, so potential difference is you in to bring a charge from a given reference point to another reference point, you have to do some work against the electric field. That's the electric potential, right?
Yes, sir.
And the difference between potential at 2 points in a circuit is called potential difference, like this. Here it is from VA to VB. We may like say that VB minus VA is 12 volt. This is the potential difference, right? Got the point?
Yes, sir.
So hold on a minute. I have to make a call to admin and then we will be back, right? So I am muting my videos and
Yes, sir.
We are back now. Electric power assignments. Slow electric tension. Draw a schematic electric system. So, yeah, tell me.
So
It's
what's
time. It's time to share some homework with you.
so can you explain what's VB?
Uh, VB is potential difference at point B. This is like, suppose this is point A, right? This is point A and this is
Yes.
point B. So corresponding to this is VB, and corresponding to this, the potential difference is VA. So if we have to find the potential difference, it's already said that the difference of potential or difference in potential at 2 points in a circuit. Okay. So if you are confused, we may draw it again. This is nothing like that. This is 2 points, which is connected with a battery. Okay. So this point is equal to this point, right? This point is equal to this point. So you have to bring, this is 12 volt. We may say A point. We may say it is B point. So potential at here is VA. Potential as here is VB. Now you have to drag a charge from here to there. So how much work you have to do? You have to multiply Q into V. Got the point?
Okay. Yes, sir.
Okay. So this was the thing.
So in you wrote right VB minus VA is equal to 12E.
Yes.
So if they give VA and VB, so you can subtract and find
The difference.
okay.
Okay. So how you calculate the difference in two quantities?
Subtracting.
How if I'll ask you to find the difference between 100 or 95, how will you do that?
Subtracting 195
So it will be the difference, right?
is 5.
Okay. So similarly, if I'll say that in a circuit at point 1 there is 10 volt and another point there is 5 volt. So what is difference in voltage? So how will you do?
Subtracting.
Right. So I'm sharing a screen with you. This is screen. Is visible?
Yes, sir.
Okay.
It's small, so I can see.
It's the 200%. I'm sorry, I can't do it. It's the maximum. Okay. So we will be sending it to your assignments. Okay.
Okay, sir.
Whatever you feel it's in, I'll try. Okay. Whatever you feel you can do or be covered from this subject, or you may use your previous knowledge. Okay.
Okay.
Even you can try if some subject is not, some topic is not being taught and you have knowledge, advanced knowledge, you may use that. Okay. Don't wait that sir will tell, then only will do. If you have knowledge, you may use it. Okay.
Yes, sir.
Okay. So I think it's time to round it up, round it off. So already we rounded that almost. What do you think? Do we have to make any recap?
No, sir.
What about Jaslyn? Jaslyn didn't interacted in this session, so I don't think she will be getting any knowledge from here today.